This is chapter 9, Law of Sines and Cosines. We've done Law of Sines. So let's look at Law of Cosines. Please copy your cuds. Alright, Law of Cosines. Again, just like Law of Sines, what we do for Law of Cosines, what you need to understand for Law of Cosines is that we use this law when we have a triangle such that we have a triangle that is not a right triangle. So angle A is not right, angle C is not right, angle B are not right. It's either an acute triangle or an obtuse triangle. Now, let's let triangle ABC by any triangle where lowercase a, b, and c are all the leg lengths, and capital A, B, and C are the angle measures. When that's true, there's a couple of things we do. I'm going to back this up and over here. Actually, let's go this way. This may throw you off just a little bit. When I have triangle ABC, when using the law of cosine, kind of like the Pythagorean theorem, you have a squared plus b squared is equal to c squared, but it's slightly different. Let's say I'm looking at A, and I want to know the length of side A, which is the lowercase a. All I need in order to find side A here is B and C, the other two sides, and I also need the measure of angle A. So the equation to find side A is a squared is equal to b squared, this side, plus c squared, this side, minus 2bc, which are these two again, cosine of that actual angle A. So I'm using side A and then angle A right there. Now, that's if I need side A here for this particular triangle. Let's say for this particular triangle, I'm looking for side B. Okay? So now, let's say if I want side B on this particular triangle, now what I do when I'm looking for side B, that means now I need A and C. And then I also need side B's angle, which is angle B. So B squared is equal to A squared, there's my A, plus C squared minus 2AC, A and C, cosine of that angle B. And that will give us our B squared value. What do you think C is going to be if I wanted side C? Well, if I wanted side C, just like when I was trying to find A and B, that must mean if I want side C, I need A and B, and I also need, in order to find side C, that angle C. So here it is. If I want side C, that means I need side B and A, and then angle C. And there it is. The equation is C squared is equal to A squared plus B squared minus 2 times the A and B times the cosine of C. And this means all these mean multiplied by the cosine of C right there in that last. Minus 2A times cosine, minus 2AB times the cosine of C. Alright? Alright, let's proceed further. Let's look at an example. Let's suppose we want to find an example for triangle ABC by using the law of cosines to determine C. And then we're going to go back to law of sines, which we learned in a previous lesson, to find the angle measures of A and B. So here we have triangle ABC. With the given information, we had side B, and I know that's number 24, side B, because it's across from angle B. And I have also side A because it's across from angle A. There's also BC or side A. Okay? Let's find C. I want side C here. I want side C such that I find that side length, which is going to be equation A squared plus B squared minus 2AB cosine C. Alright, looking for this particular equation, I ask myself, do I know A? I do. It's 18. Do I know side length of B? It's 24. There's our A and B again, the 18 and 24. The cosine, do I know the measure of angle C? So if I check everything off, do I have A? Yes, 18. Do I have B? Yes, 24. A again is the 18. B again is 24. Cosine C, I also know, which is going to be the 57 degrees. All right, by substitution, now I'm coming in here and I'm going to say, I just wrote it down here because all this will get in the mess there. So I have C squared is equal to, our A value is 18 squared plus, by substitution, B is going to be 24 squared minus 2, which which is brought down, times A, which is the 18, times B, times the cosine of 57 degrees, which is the angle C. Now all you do is just plug everything into your calculator. Right? So here we have 18 squared is 324 plus 24 squared is 576 minus, I do 2 times 18, which is 36. 36 times 24 is 864. And I want to multiply 864 by the cosine of 57. Let's remember, cosine 57 degrees is actually a real number. You take out your calculator and you plug in a cosine of 57 degrees and you find out what number that is. 0.054463 something, something, something or another. Okay? And to do this particular problem here, c squared is equal to, I'm just bringing the 324 down, plus 576 minus 864 times 0.5446. Okay? Because I took the cosine of 57 degrees. These are being multiplied. 864 times the cosine of 57 or multiplied by the 0.5446. Okay? Bringing everything down continually. 324 plus 576 minus, when I multiply 864 times that 0.05446, and I actually left all of these digits in my calculator like this. So I'm going to take my last answer, and that's the answer because it's my last answer, being multiplied by, I believe that was, what was it, 864 times 864. Such that I get 470 and 5/10, or 6/10 if I round, excuse me. And you can see this is where I get that value there. Now, by order of operation, I'm going to start do my addition and subtraction from left to right. I'm going to have 324 plus 576 is 900, minus 470 is brought down, 470.568 is brought down, minus 470.68. And when I subtract that, c squared is going to be equal to, c squared is equal to 492.43. But I don't want c squared, so I have to take the square root on both sides. The square root is approximately 20.722. Okay? Once I have that square root, now I can come back here and put this c value in here at the top. C is approximately 20.7, I believe, 44 something or another from down here. And there it is. Okay? Now you're asked to find all the angles inside. So how do I find angle A or angle B? To find these particular angles, now we go back to, because we have all three sides. Did I put this in? I did put this in the wrong place. Side C is approximately, 20 and 7, since I wrote it up here from the last example. I have all three sides in one angle. That means now I can go back to that old stuff we learned from the sine. Sine A, talking about the law of sines, equals sine B over B equals sine C over C. Now, when we do this, we look to see what we have. First of all, I know one thing I clearly see. I see angle C and side C. So if I see I have angle C and side C, I know I'm going to use the sine of C. That's done. Now the question is, do I want to use sine A or sine B here? Well, let's look and see what I have. For A, I don't have the angle, so this is out. But do I have the leg length of A? And I do. It's 18. So which two am I going to compare? I'm going to compare sine A to sine C. Those are the two that I'm going to use. And I'm going to squeeze that in here. So I'm doing the sine A over A equals sine C over C. And by substitution, I just plug everything in now. Okay, sine of A. So now I'm going to sine of A, which is unknown. I don't know what that is. Over, what's the length of A? It's 18. Equals the sine of C. What's C? Okay, that angle measures 57 degrees. So that's the sine of 57 degrees over, what's the length of C? The length of C is 20 and 7/10. Okay? Now I'm going to erase this here. Make a little bit more room on here. have a little bit more room. Hopefully you got all that copy, but you can just rewind the tape here. So here we have this sine A over 18 equals sine C, which is a 57 degrees over 20 and 7/10. I'm going to remember sine 57 degrees has a real number. So I just come back to my calculator and I find out what the real number is, the sine of 57 degrees. Oopsie, I put 557, so let's fix that. One too many fives. And I get 0.83867 something or another there. Okay, so I'm going to rewrite this as the sine. So now my screen wants to mess up. Sine of A over 18 equals the sine of 57 was 0.839, I think approximately. Let me look here quickly, and it is. So there it is, over 20 and 7/10. I divide these two numbers together here. So let's divide this 0.89 in here by 20 and 7/10. So I would leave this whole number, and I would divide it by 20 and 7/10. And I get 0.04 something, 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 something here. So we're almost done. So I get sine A over 18 equals 0.04. I think that was 0 something here. It is 5.1. Okay, that's after I divided these two numbers. This gives me here. Well, I want sine A on the side by itself, so how do I get 18 out of the denominator? I want to multiply both sides, basic algebra problem, both sides by 18. This will drop out. What am I left with here? I'm left with a problem such that I get sine A on the left side equals this number here multiplied by 18. I'm just going to take this last number I had there and multiply by 18. And I get 0.729 something, 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 something. So I just come in here. The sine of A is equal to 0.729 something, something, something. Is equal to the sine of A. Well, I know the sine of A is as a decimal, but what's the angle measure? Remember we talked about this before. I want A by itself, so that means I need to do the inverse of this number. 0.29. That's going to give me the measure of angle A. So I'm going to do the measure of angle A equals the sine inverse of this 0.729 number. All I'm going to do is take here, I want that number, I want the inverse, shift inverse, remember that inverse, and I want that 029 number, 0.729278 75, and I guess I use all the numbers and close parentheses, and what do I get? That's approximately 46.8 degrees. Alright, so the measure of angle A, let me quickly do that, 46 and 8/10. So the measure of angle A is equal to this value here. So I can come to the top, and I can put this in here, 46 and 8/10. And to find the measure of angle B, we just use what? Triangle sum theorem. I've got this and that. All you do is add 57 degrees plus 46 and 8/10 degrees, and that equals, let's see here, plus 57, 103.8, or 103 and 8/10. Okay, and to find that B, I'm just going to subtract 180 degrees minus that 103 and 8/10, and it'll give you your answer. So 180 minus my last answer there leaves me with 76 and 1/10 degree, or 2/10 degree. All right, so the measure of angle B is equal to 76 and 2/10 degrees. You can just put that up there. And there's the law of cosines and sines mixed together.